Hey, I understand that this linear separability issue is a little complicated, or particularly this slide. Um, but the important thing, I think, is, if you set the weight, say if you set weight two to be greater than the threshold, right? That will accomplish this second row where only input two is true. And if you set the weight one to be greater than the threshold. That accomplishes this third row when input one is one. However, doing that will necessarily result in when both the weights are added, they'll be greater than the threshold, which means uh, that this would actually be one, right? This fourth row, right? When both the inputs were one, this would lead to the output being zero. Okay. Okay. In other words, an XOR function is impossible when you just have like two layers of nodes or units. Okay, so now we're going to talk about a multi-layer network. Now, a multi-layer network, this is just a simple multi-layer network, right? So we have two input units, we have two hidden layer units, and then we have one output layer, which is just one unit, okay? And so let's see. Let's do like our truth table. Okay. And first we're going to model, or we're going to figure out what the output is, or the input, I should say, to H1 and H2, and then what their output is, which goes on to the output layer. So let's see. So if the both of the input units are, if both the inputs are zero, right? Excuse me. So zero multiplied by this weight, which is one, and then zero input two multiplied by negative 0.5. That leads to zero plus zero is zero, right? And then if we do this again, we do this for the hidden unit two. So then we go zero multiplied by this weight, which is of negative 0.5, which is zero, plus zero times this weight, which is one. When you add those two together, you get zero. Okay, great. So this input to this second hidden unit is going to be zero. And then when input one is zero and the input two is one, then, well, we got zero times one, that's going to be zero, and then one times negative 0.5. Well, when you add those together, you get negative 0.5. Let's do it for this one for H2. So 0 multiplied by the weight, which is negative 0.5, plus this input, which is 1, times this weight of 1. Well, when you add those together, those products together, you get 1. And then what about when input 1 is 1 and input 2 is 0? So now we got this input of 1 multiplied by this weight of 1 plus that's one, okay, and then plus, right, zero multiplied by this weight of negative 0.5, that's zero, so it's going to be one plus zero equals one. Great, let's do it for H2. Now we got one multiplied by negative 0.5, that's going to be negative 0.5 plus zero times one, which is going to be negative 0.5. Now let's do the last one when both the input units are one. So uh, 1 multiplied by this weight of 1, which will be 1, right? Plus 1 times negative 0.5. So it's 1 plus, or 1 minus 0.5, which is 0.5. So 0.5 will be the input to uh, uh, hidden unit 1, right? And then let's do the hidden unit 2, right? So 1 multiplied by this weight of negative 0.5 plus 1, this input of 1 multiplied by this weight, which will give you negative 0.5 plus 1, right, which is 0.5. Okay, so these are the inputs, right? So if these are the inputs for the input units, these will be the inputs into the hidden units, right? Well, what are the outputs to the hidden units? Well, it depends on the threshold. In this circumstance, or this instance, the threshold is one, right? So if the input, sorry, if the input of each of a unit is greater than the threshold, then it fires and it becomes one. And if it doesn't, it's a zero, right? So let's go through it, right? So just to be clear, this is the entire network, right? Uh, and so let's see, right? If these are our inputs, well, both our inputs, right, are less than one. So then that means the outputs are going to be zero. And then if we do this for this one here, right, so this input is negative 0.5, so that's less than one. So that means that the output for this H1 is going to be zero, whereas this output, the output for H2, sorry, is going to be one because it's equal to one. And then we can do this here. So then the input into H2, right, when the input to input one is one and the input to input two is zero, right? In this circumstance, uh, well, okay, the input to hidden unit one is one, which is fine. That's good. That's the threshold. That's equals the threshold. So it turns into a one, whereas negative 0.5 is not greater than one, not even equal to one. So it's going to be zero. And then finally, we can do this here, right? So when the when the input one and input two are both one, well, that means that the input to H1 and input, or sorry, the input to H1 and H2 are both going to be zero point 0.5, which are less than the threshold of one. And so the outputs turn into zero, right? And so now if you plug in these outputs, right? The outputs of H2, and you plug them into you multiply them, sorry, by the weights, right? You'll get an output. Or you'll get an input, and then that if that input is greater than the threshold or equal to the threshold, then the output will be one. Then it will fire, right? So if that's the case, right? So if both the inputs, if both the inputs into this output unit are zero, right? So zero times one plus zero times one. Okay, so the output is zero, or the input, I guess, is yeah. The I get input and output a little mixed up, but in this case it's zero, right? The input is zero. The input and the output are going to be the same thing, is my point in this example, right? So if it's zero times if the input or the output to H1 is zero, and the output for H2 is one, so then zero times one is one, plus one times one is one, right? And then you do the same thing here, but now the expressions are reversed. So one times one plus zero times one equals one. And then zero times, these are going to be, so the outputs to H2 or the inputs to the output layer or unit is going to be zero times one plus zero times one equals zero. Um, and yeah, that's how we do the XOR function. So I know that was a lot to digest or process. Certainly was a mouthful for me, but I wanted to go through this XOR function in a very thorough fashion. So hopefully it helped. And yeah, in the next video, we'll talk about multi-layer networks.